Yes. So even this, as you saw here, the satellites that are inside the Earth's magnetosphere and protected from solar wind, they do encounter plasma, and that is the plasma that's trapped inside Earth's magnetosphere.
जी मुझे बहुत शौक है इसके अंदर ना इतना
Yeah, this is not that. It's not a like simulation for that specifically.
वही ना ये देखो
Yeah,
मैग्नेटिक फील्ड
yeah,
है
because this is much more
ये
compressed here. Yes,
तो इस मैग्नेटिक फील्ड है shouldn't be this uniform.
yes, ma'am.
You can start again.
In the direction
Yes.
of the solar wind there should be a
Well, basically, he's saying that the magnetosphere here should be much more compressed because of solar wind. But this is a simulation for showing how many spacecrafts are in our environment.
So you're the purpose, you're
Yes.
trying to show how many spacecrafts are in the environment, or you're trying to show the magnetic field?
We're trying to show the spacecraft that are inside Earth's magnetic field.
So magnetism has a huge role in this,
Yes.
right? So what are the magnetic properties of Kapton?
The magnetic properties of Kapton. Man, it's insulated. It doesn't really have any effect from magnetic
There's no
field
effect.
or.
Are you sure?
Ma'am, I did write
You
it
please check
somewhere.
it
I'll check it out.
and
yes.
write about this in your paper, okay? So
Ma'am, there was another idea which was about Faraday's sphere
okay,
to
yes.
shield a satellite. So
Yeah.
in that we basically create a field around your spacecraft, but its inevitable drawback is that that sphere will have consequences and effects on the electronic instruments of the satellites. So it was the main reason this idea was discarded.
Okay, can you escape this and go back to your presentation? Okay, Tayyib, do you have a question?
No.
Okay, so please go back. At the beginning, right? Yeah. So you have the challenges of, can you come down? Come down, please. Yeah. You have ultraviolet radiation. So what is the effect of these radiations on Kapton?
Since it's an insulator, it's have much better properties than other. But
Much better is
ultraviolet basically it's how should I say this? Its damages inability because this is very high energy electromagnetic radiations. So it takes some, like Kapton is a sheet, a polymer sheet, elastic sheet. So there are some picture that I didn't add that was like it showed the sheet.
You can add that picture in your paper,
Yes.
okay?
So basically this was the Kapton sheet, and some holes would start to appear over time because of the ultraviolet radiation and high energy electrons and all of that. So after some time, this holes would connect, and this Kapton material would have now a huge cavity inside.
And this is damaged.
Yes.
So now it's not possible.
Yes.
And how much time does it take to get damaged? Like what is?
Yes. As I said, the average life of a satellite is 9-10 years. So basically, that's the life of this polymer as
So
well.
these holes take like 9-10 years to heal.
Yes. I mean, they start to appear like after 7-8 years, but for it to be completely destroyed, it's like 9-10 years, or maybe a little bit more than that.
No, but we want optimal performance of the satellite.
Yes.
So we cannot wait for it to be completely destroyed. We need
Yes.
it in a
Yes.
suitable condition to function. And satellite
Yes.
is a
Yes,
very
ma'am.
important.
Yes.
Okay. So go back to the challenges, please. Okay. So ultraviolet radiation, high energy electrons. What are the effects of high energy electrons on the?
These are all basically high energy electromagnetic radiations, and that basically have this same effect that I have just discussed.
And Kapton is good enough for this.
It's a polymer that's right now is first choice since 1960s.
It's not being affected by these radiations.
It is affected by this radiation. That's why the satellite's life is only around 9 to 10 years.
But 9 is a lot.
Yes, but that is for them is good enough.
In
So
such a harsh environment,
yes, ma'am.
it can function for up to 9 years.
Yes.
That's good enough.
Yes.
Okay. So in your paper, have you given a separate heading for this?
Yes.
And you've explained every part of this?
Yes.
Okay, the next slide, please. Okay, now this is also very interesting. You've talked about very important aspects, material aspects.
Yes, ma'am.
And for example, in your paper, have you given a heading for thermal properties?
Yes, I've given heading.
Each of these will be
Each
a
of
separate
these
heading.
separate headings. Yes.
Yes.
And
And
I've
you've
discussed all of
explained
them. Yes, with some examples as well.
Yeah, and also using the concepts from the book, the laws, the equations, or the concepts from the book.
I will add that part yet. I haven't added this part yet in that.
Okay, yes, you can improve that.
Yes.
You can add the phase diagram, you
Yes.
can add the thermal properties from the thermal
Yes.
property chapter. From the thermal property chapter, you get the concepts, the equations, the laws, but then for your particular material, you have to go to your own references. Right?
I only read the chapter 14. I guess it was in the book that was only about polymers.
Okay.
So this was.
Now you can look into the chapter on thermal properties.
Okay.
In order to write about this part, okay, this will be
Yes.
a separate heading. Then you can look at the chapter about mechanical properties and you can write about the second heading.
Yes.
Then you can look about the chapter about the chemical properties and you can